Hello everybody and welcome to Chat from the Engineering Desk. Today we're going to be elaborating a little bit further on the musical themed Arduino video which I did recently. What I've got here is our piano, and it shows up top the frequency of the note that we've just played. So with each chord frequency doubles. An important thing to note with how chord progression works on the piano. So you got 8 octaves. Each time the frequency doubles. So now let's have a look at our Arduino code. Come on. As you can see, I've added some stuff and modified a few things. I made all those bottom buttons the white keys. I made the top buttons the black keys. And there's an 8th one, which is C in the next octave. And over here, I've put in a pot, and with that we select between the 2nd or the 3rd octave. So if you're going to be playing it, you'll generally be using 2 octaves. So there it shows 130 Hertz for the C in octave, in 2nd octave. If I select the 3rd octave, the frequency doubles. In pitches.h, one can see that. So that's C in the 2nd octave, C2, let's see, 2nd, C2, yeah, so 65, C2. What are we looking at? Oh, yes, I'm thinking about 3rd octave, would be the 2nd one. So going back to our drawing in the code, I added in the screen, so it shows us the frequency of the note being played and which octave we're playing in. So for that I've added in liquid crystal I squared C, which is wired up over here. We've told it which display it is, and we then over here LCD initialize, backlight on, cursor on position 1, line 0, print my piano note, and then it shows up there. Now some minor things have changed elsewhere. We've added pin 13 and then 3210 as digital inputs, and in the array we have added the pitches that we want to call up from the lookup table. So what do we do down here? We read the analog 0 in, and we put that value into val. We then take that 0 to 1024 value and divide it by 512, which then gives us a value of 1 or 2. And I then add 1 to it, because we're working with the 2nd and 3rd octave. And then if we're working in the 3rd octave, we have to double the pitch. So that's what the +2 is for. Now you'd have to do your maths a little different if you wanted more octaves in your selection. In this case it's 1 or 2. It then moves the cursor to the bottom line. It writes a frequency using the same calculation. It then puts a bit of text behind it. And it then prints the value of the octave. And then it prints a blank space behind that. It's going to stay there unless you write a blank space to it. So looking at the code, this editor, if you've made a code change, like I just changed that to capitals, you just do that. Now those have become capitals. So that's how you change code on the fly with the simulator. So going back to our piano, C2, 65 Hertz. That's the next octave, so it's double that. So let's go back to our sketch. So if you go in there, we are currently, what have we done? We are playing the wrong octave. So that's the next octave. So that would be the keys that we've got in our simulator. There you can see the progression up there of the frequency. So if I change it to the next octave and we play those same keys, it should sound like that. Let's try that out. So there's alright. Next octave. Now remember, this is going to be the same frequency as that key was in the previous octave, so it doesn't change much down there. There's a little bit of rounding errors and things going on in my maths, but we're just having fun here. Speaking of which, why don't we quickly fit in a joke here? How many concert masters does it take to change a light bulb? Just one, but it takes 4 movements. Alright, and moving on. What part of the turkey is musical? The drumstick. Okay, let's be serious here. Nah, let's continue having fun. So now we've said that's 200, that's going to be the same note as we had in the previous selection. So the frequency goes up. Let's see how that compares to the piano. We played that. as we saw on the Arduino. So things that I added in conclusion is the black keys. Added this pot, which gives us either a 1 or a 0, a 1 or a 2 for our octave selection. And then we added the screen so we can see in which octave we're playing, on which key in other words, and the frequency of the note that we're playing. Here we had to add the notes, some more notes from the lookup table, because we now got 14 keys that we're playing, and the stuff for the LCD. What rock band has 4 guys that don't sing? Mount Rushmore. Anyhow, so there's that long table, all 88 notes. So I've been having a lot of fun with this. I can add stuff. It's so quick to get stuff done in the simulator, which is nice. It works really well. If we stop it, I can show you all the hardware that's available there. There's lots of stuff to play with. You can do motion stuff, play with displays, play with lighting stuff, all sorts of good stuff. In conclusion, what did the robbers take from the music store? The loot. I'm going to wrap it up here. Hope you enjoyed it. Learned a little something, a little extra from it. Be nice if you comment if you feel free to do so. You're welcome to subscribe. Hit the notification bell so that you are aware of it when there's more of my videos coming out. Do them on a regular basis. And for the rest, have yourselves a wonderful day further, a lovely weekend. I'll see you here for more. Thanks. Cheers.